So the simulation is finished, and as you can see, it's quite different than what we had before. The reason for this happens quite often when you increase the resolution of your simulation, but in this case, it's kind of obvious what the problem was. So the main issue I had on my setup, let me stop this. So the main issue is going to be the fact that when we increase the resolution of our simulation here on the smoke object and we reduce the voxel size 0.005, what happened was that the size of our source is actually connected to that. Let me disconnect this. It's connected to that. So as you can see, we have a lot smaller points. So these points are now a lot smaller, and we don't have enough density for them to actually give us a consistent result. So in this case, the solution isn't really necessarily to just increase the number of points or the density of the scatter that we did. But we can actually just simplify things and use the particle scale that's higher. Considering the distance that we have between these points, I would say 0.01 should be the minimum value they would get for these particles that are emitting the smoke. So if you want to play it safe, maybe even bigger, 0.015, and this will give us some much more consistent source, as you can see here. Okay. So that's probably the main reason. The other thing you can do still is we can still consider and let's actually see the difference between having 0.005, okay, and 0.015. So it's a pretty big difference. Maybe 0.01 might be enough, but if you want to go with something like 0.01, then what I would suggest is for you to increase the density multiplier. That's another thing we can do. So here on the volume source, I'm going to increase the density multiplier to 5. And this should be okay. Let's go ahead, and I'm going to cache this out again, and hopefully now we would get the expected result. So see you in a bit. So here is the final simulation that I cached. I did a couple of iterations in the meantime and a few adjustments to the settings of the simulation, and I'm going to go over those as well. Let me just stop this. So the main changes that I did was regarding the intensity of the turbulence. So here on the burnout sim, when we go to the top network, you'll see we have here on the shape, the intensity of the turbulence was pretty high. I had this at 0.6. It's not noticeable in the beginning. It's more noticeable, but it was really noticeable in the end, and it was kind of agitating things a bit too much for me. I could probably still lower it a bit, but the result that I have right now, I think it works. The other solution that we have for slowing down things, and that's also something that you might consider, is here on the simulation you can just bring down the time scale. I think this would also help. So I'm going to bring the time scale to 0.7 and probably simulate again, cache it again, and let's see. I'm not going to change anything else around here. Maybe you lower the disturbance to 0.2. I think that'll be enough as well. There's already so much going on because of the velocities of our source and the motion of the wheel and all that. We already have a lot of things going on, so it's not the case where we're really dependent on these effects to get a nice result. So with these adjustments, I'm going to move on to the final simulation, final cache, and I'll be back as soon as it's done. So here is the final result of the simulation. With the latest adjustments we made, this result is much more satisfying than what we had before in terms of the speed of how the simulation evolves. Lowering the time scale really was probably the most efficient adjustment that we made, and yeah, that's it. So on the next lesson, we'll start having a look at how we set up things for rendering.